Hey, good afternoon. It's Mr. Chow-Miller. The presentations you're about to see are my Gateway to Technology classes describing and explaining the different mechanisms that they built. They built all these mechanisms on their own. They didn't have directions or anything. All they had was a picture and description of the mechanism. They had to figure out how to build it, how it worked, and then research and present information on each mechanism. So please enjoy.
Hi, I'm Kylie.
I'm Tara.
I'm Callie, and this is our differential mechanism. This is the input gear, and the motion is rotary.
Same thing for output motion. The output gear is rotary as well. Is the direction reversible? Yes, it is, because if you turn this handle one way, it can go, and you can turn it and it'll go as well.
There is an increase of speed because if you turn the bigger gear, it turns that way. Oh, and the power can go two different ways. If you turn this gear, it will move the bigger gear, and if you turn the bigger gear, it can turn
Our mechanism is designed to turn two different gears at two different speeds.
An example for our mechanism in real life is this video, or an axle, where you have a car, one will turn a sharper turn and one will turn the more amount of turning.
Excellent. Can you demonstrate that on your mechanism itself?
Yes, so if you turn this one is turning as well, and then if you turn this one is turning as well. So if you have right here as well, so if you hold this, you can turn this.
That's what I'm talking about,
And then if you hold this, then you can turn this as well.
Excellent. Thank you very much.
Hi, my name is Abby.
My name's Jasmine.
And I'm Belle. And our mechanism is a Bevel Gear. The input movement of our mechanism is rotary, as well as the output mechanism.
And the direction of travel is reversible because you can turn it this way and this one will turn that way, or you can turn it this way. And the direction of the flow of power is reversible, and the mechanism is designed to increase speed because the bigger gear is the leading gear and this one's the smaller gear.
If we had two same-sized gears, then the bevel gear would simply be used to change the direction of movement 90 degrees. Right here we have a real-life example of the bevel gear. Because we couldn't bring a real car in, we have a Lego car. In the front there's a bevel gear that when you spin the motor, the bevel gear turns, making the wheels spin.
Cool. Thank you very much.
I'm Alex.
I'm Ryan. I'm Riley. And our mechanism is the lead screw. Our input movement is rotary because the screw moves in rotation. And our output is linear because the shuttle moves in a straight line. Our direction of travel is reversible. The shuttle can go left and right. And our flow of power is not reversible because I can't move the screw using the shuttle.
And the lead screw is torque over speed because you can't stop the shuttle with your hands when moving the screw. And the wheel spins faster than the screw.
In a real-world application where you can find this is the device. And that's it.
Hello, I'm Fausto.
I'm Kevin.
I'm Tim.
And this is our chain drive. The input motion is this handle thing. And the output motion is this wheel. Yeah.
What the chain is used for is like dirt bikes and other bikes that you ride around.
Ta-da!
Can you tell us anything about whether yours increases speed or torque the way it's set up?
I think it would increase speed.
Yeah, I think speed.
Okay. Is the direction of travel reversible?
Yes.
Yes.
What about the flow of power?
Yeah.
Yeah, because...
Show me that. That's the direction of travel. Now show me. There you go. That's the flow of power. All right. Thank you very much.
I'm Eden. I'm Cassie.
And this is our mechanism. It's called the rack and pinion.
The way its power is by rotational movement or the moving of the lead gear.
The output motion is linear because when you move the input gear, this goes in a straight line. in either direction.
And the direction of travel is reversible because it moves back and forth, left or right, depending on which way you turn the lead gear.
The power flow is reversible because you can move this as well as the gear, and the same thing will happen. So you can move this and it'll still transmit to this gear.
The rack and painting is designed to increase torque.
And it changes movement direction because it can go back and forth, and the amount of torque or force available to do work.
And it can be found in real life in the steering system of a car, just like this. You can see it right there.
Right there in the middle.
Lock gate controls and stair lifts, and the clicky ice cream scoopings.
Cool. Thank you very much.
My name is Noah Hall.
I'm Carson Mulkin.
I'm Josh Brewer.
And this is the universal joint.
The angular range between the input shaft and the output shaft in which the mechanism will work is any angle between 90 degrees and 180 degrees.
The speed is constant. The input shaft is turning the output shaft, but there's no size difference.
So the torque is also constant, obviously you can see.
The speed ratio of the input shaft to the output shaft is 1:1.
So the flow of power is reversible because you can turn both forward and backwards.
The input and output shafts turn in the same direction.
And an example where this mechanism could be used in real life is in the steering columns of many vehicles.
Cool. Thank you very much.
Hi, my name's Maddie,
My name is Lailani.
and we made the crank and slider,
The crank is the input of energy.
and the slider is the output.
The direction is reversible because it can go forwards and backwards.
But the flow of energy is not reversible because the slider cannot be the input.
It changes the motion to rotary to reciprocation.
And you can find this mechanism on the wheels of a train.
Thanks for watching.
I'm Naomi.
My name's Chantel.
And our mechanism is the worm and wheel.
The angle of the input compared to the output is 90 degrees. The speed of the mechanism has decreased. This is our wheel. This is our worm gear, and this is our wheel gear.
The torque of our mechanism is increased.
The ratio is 24 to 1, and the flow power is not reversible because you can't have this over here and expect both of them to move. So you have to have it over here.
The direction of travel is reversible because you can move it left and right and it'll spin both ways. And then an example of our mechanism is on string instruments on the tuning pegs. Thank you.
Excellent. What type of motion is the input and output on your mechanism?
The input is rotary and the output is rotary.
Cool. Thank you very much.
I'm Bonnie.
I'm Mariana.
And our name of our mechanism
is the chemical follower.
Our input gear is the lever to turn. That's the input. And then our output gear is the follower. And then the direction of our travel. The direction of travel is not reversible.
Because you cannot
Go back.
backwards.
Go one way.
Our flow of power is not reversible because the follower cannot turn the cam. And then I think I'm skipping one, but it is used to increase torque. You can find our mechanism because it is a pump, also known as a pump jack, which is an oil drill on land.
Excellent. Anything else?
No, sir.
All right. Thank you very much.
And I'm Earl. And we're doing our presentation on the crank and slider mechanism.
The input motion is rotary
And output is reciprocating.
The direction of travel is reversible because you could crank it either way.
But the flow power is not reversible because you can't do this and get like a full spin. It will not work.
It's not designed to increase torque or speed.
But it's designed to change rotary motion into reciprocating motion. And our example is a picture of a train.
Excellent. Thank you very much.
Hello, I'm Anthony. I'm Ben.
I'm Chase.
And this is the Bevel Gear. Bevel Gear is goes reversible.
What's reversible?
The input and output. So input has 24 teeth, and the output has 32. And it's reversible, as you see, and it's used for torque. So it's used in trains, and in the Marines. And yeah.
Anything else? Okay, thank you very much, guys.
Alright, I'm Gerry Johnson.
My name's Chris Jennings. I'm Brooklyn O'Hare.
Alright, and the input movement, it's a rotary movement, how this works.
What's the name of this mechanism?
Directing pinion.
Yeah.
Excellent.
And the output movement it's a linear, the way this works. And you can find this in a car. When you turn the steering wheel, it turns this bar, which turns the wheels.
What changes?
Neither. They are constant.
Okay, so the angle of the output changes, right?
Yeah.
Okay, thank you very much.
And this is our mechanism lead screw. Our lead screw is input movement is rotary, and the output movement is linear.
Show us.
The direction is reversible, and the flow of power is not reversible.
They're typically used to carry high power, but not for intermittent use in low power actuator or positioner mechanisms. Used in intermittent, used in low power actuator, it's the same thing.
If it's used in a car jack, used for car jacks.
Okay.
And that's our project on the screen.
Thank you very much.
My name is Mason Hayes.
I'm Mason Olson. And I'm Kinsey Anderson.
And we are here today to present the Differential Gear, and that is our mechanism.
The input movement of our mechanism is rotary, and the output movement of our mechanism is rotary.
As you can see, it all rotates as one.
The direction of travel is reversible because you can spin it counterclockwise and counterclockwise, and the flow of power is reversible because you can spin the wheels this way, but you wouldn't really want to turn back up your car by spinning the tires with your hands, so that's not really what it's meant to do. And our mechanism, it increases speed because we have a big gear right here and a smaller gear, but our mechanism is not designed for that. It is designed for when you are turning a corner, one wheel spins faster while one wheel spins slower.
As you can see down here, one wheel's not spinning and the other one's spinning.
And if you hold this one, that wheel will spin.
You could find this mechanism in a car, like our example here. If you try to turn a car, one has to go slower and one goes faster so that it turns all the way over. Because if you try to go in both speeds, you're not going to be able to turn. And that is our presentation about the differential gear. Thank you for watching.
I'm Emily, this is Orion and Polly, and this is the belt drive. The input movement is rotary, and so is the output, which is this part.
The flow of power is reversible, and when you turn it this way, it can go to the left, and this way it can go to the right. And the flow of power is not reversible when it's like this. You can go like that and twist it. It goes the opposite direction.
The belt drive is used to increase speed and decrease torque, and it's mostly used like in bikes to transmit power from the pedals to the wheel. Like that would be where you're pedaling, that would be the chain, that would be the back tire.
Okay, anything else? All right, thank you very much.
This was made from Sean and CJ. It's called the chain drive. The direction can be reversible, but only by turning the handle in different directions. And it's not also used in rotary. The speed can be increased, and you can also find this in a bicycle.
CJ.
What else? And cars.
Cool. Anything else, guys?
Nope.
Okay, do you know if this particular mechanism increases speed or power the way you have it set up?
It can increase speed, but it takes a while.
Okay.
The handle is a little bit tighter.
Yeah.
Than its
Cool.
normal average.
Thank you, guys.